solving trig equations. Just very quickly to reiterate two critical points here on our quiz, and basically you have seen me do this every single time in class. I want to know the general solutions and the specific solutions within this interval. I want both in writing every single time. Another thing to remember, we're going to look for opportunities to set equal to 0 and factor. This is always a good option no matter what we're doing. Or we're going to look for an opportunity to make a substitution. So, first problem here, cosine squared plus sine equals 1. So with this particular problem, we've got two different trigonometric functions. So we need to rewrite one of them in terms of the other. We do not have an option to rewrite sine in terms of cosine, but we can rewrite cosine squared in terms of sine. So let's put that in. 1 minus sine squared plus sine x equals 1. So let's put this in descending order, and then we'll set equal to 0 as well. So 1 minus sine squared x plus sine x minus 1 equals 0. And from there, 1 minus 1 cancels, so now we have negative sine squared x plus sine x equals 0. Now we can factor, and we can factor out the GCF, which is sine x. We take out sine x, or even better, take out negative sine x, and that leaves us with sine x plus 1 equals 0. So now we've got two factors, factor number 1, factor number 2, set each factor equal to 0. Negative sine x equals 0, sine x plus 1 equals 0, sine x equals 0 if we divide both sides by negative 1. So we can get some solutions here. Where is the sine equal to 0? The sine is equal to 0 here at 0 and also at pi. Now, these are our two first specific solutions, 0 and pi, and then also we can get our first general solution here, x equals pi times k. Remember, these are pi units apart no matter what direction we rotate on the unit circle. So 1, 2, first two answers. Next, sine x equals negative 1, x equals, where's the sine negative 1? Only at 3 pi over 2. So next specific solution and next general solution, 3 pi over 2 plus 2 pi k. So here we go. These are our three specific solutions, and these are my two general solutions. Every single time I'm looking for general and I'm looking for specific. Next, 2 times cosine of x over 2 plus 1. So isolate the trigonometric function first. So cosine of x over 2, 2 cosine of x over 2 equals negative 1. Divide by 2, divide by 2. Cosine of x over 2 equals negative 1/2. Now, let's go to a substitution here. Let q equal x over 2. So if q equals x over 2, then cosine of q equals negative 1/2. This is something that we can pretty easily solve. Think about where cosine is negative. Cosine is negative in 2 and 3. So the cosine is negative 1/2 right here at 2 pi over 3, and also here 2 pi over 3, 3 pi over 3, 4 pi over 3. So those are going to be my solutions for q, but I'm not after q. So we're going to start with our general solution for q. Q equals 2 pi over 3 plus 2 pi k, as well as q equals 4 pi over 3 plus 2 pi k. We don't want q. We want x. So we're going to make our substitution back in. So swap out the q's for x over 2. X over 2 equals 2 pi over 3 plus 2 pi k. And x over 2 equals 4 pi over 3 plus 2 pi k. The next thing we're going to do is we're going to solve for x by multiplying everything by 2. Times 2, times 2, times 2, times 2, times 2. So this allows us to solve for x. We get x equals 4 pi over 3 plus 4 pi k. That's the first general solution. The second one, x equals 8 pi over 3 plus 4 pi times k. Now, we could go into making substitutions here, but please notice what we've actually been given here. 4 pi k is what we're going to be adding. So right away, I know that we're not even going to use k equals 1. The next thing to think about is truly what does this 1/2 x actually do to the graph? Let's take a quick look at the graph and notice what's happening with the period of the graph. So if we graph the y equals the cosine of x over 2, be reminded what that does to the period. It dramatically stretches the period. So if we want to know, and let me zoom in so you can see that better. There we go. It dramatically stretches the period. And if we want to know where the cosine, this particular function is equivalent to -1/2, let's run that horizontal line through it. And this that we can see on the screen of the calculator is only from 0 to 2 pi. We see that there's one and only one solution here, which makes sense because if normally we have 2 solutions, if we multiply that by that b factor, we should only get 1, which is what's going to happen when I let k equal 0. If I let k equal 0, I find that x equals 4 pi over 3. If I let k be equal to 0 here, then I get 8 pi over 3, which is already bigger than 2 pi. So my one solution that exists within this particular interval of the domain is 4 pi over 3. Of course, these are my 2 general solutions because obviously we have infinitely many solutions, but only one exists within the interval between 0 and 2 pi. Next, sine x plus cosine x equals 1. Again, this is a situation in that as it stands, we cannot factor, we cannot make a substitution, it's not an identity, we got to do something different. This is a good time to square both sides. Remember, this is an equation, and we can utilize the properties of equality here. Whatever we do to the left-hand side, we can do to the right-hand side. We're not verifying, we're solving. When we square sine x plus cosine x, we end up with a perfect square trinomial. Sine squared x plus 2 sine x cosine x plus cosine squared x equals 1. Next, sine squared plus cosine squared is equal to 1. So 2 sine x cosine x plus 1 equals 1. Get rid of the 1's, and now we are down to 2 sine x cosine x equals 0. We can divide by 2 and get sine x times cosine x equals 0. So finally, we're all the way to there. It's set equal to 0. It's really already factored. So let's set each factor equal to 0. So where does the sine equal 0? The sine equals 0 on either end of the x-axis at 0 and pi. So we get two specific solutions of pi and 0. Sorry, I didn't put them in the right order. That would give us general solutions of pi times k. Next, cosine x equals 0. Cosine equals 0 at the top and the bottom of the coordinate plane. So that is going to be pi over 2 and 3 pi over 2. Now, we've talked about in class, general solution, sorry. So pi times k and then pi over 2 times k. So these are my two general solutions, my four specific solutions. But we've talked in class about whenever we square both sides, we've got to go back and we got to plug in our specific solutions to be certain that we don't have anything extraneous. So let's go back and let's check them out. And check out this first one, pi. Remember, we go back to the original equation to do this. So, all right, is the sine of pi plus the cosine of pi, is it equal to positive 1? The sine at pi is negative 1, and the cosine at pi is 0. So is this a true statement? No, it is not. Get rid of pi. Next, plug in the 0. Is the sine of 0 plus the cosine of 0 equal to 1? This is 0 plus 1, and that one is true. Hooray, that one works. Let's plug in pi over 2. The sine at pi over 2 plus the cosine at pi over 2, does it equal 1? The sine at pi over 2 is 1. The cosine at pi over 2 is 0. Yes, it checks. Check. 3 pi over 2. Spoiler alert, it's not going to work. I'm running out of room right there. I'll move it right here. So this is going to be the sine at 3 pi over 2 plus the cosine at 3 pi over 2. Does it equal 1? Nope, because the sine at 3 pi over 2 is negative 1 plus 0, and that is indeed not equal. So, nope. So these are our two real solutions. So the general solutions are a little bit cranky there. They're still the general solutions, but we've only got two specific solutions that actually work. Remember, super tricky when we square both sides. Last problem. And we talked today in class about anticipating the number of answers that we're going to have. So here we have 2 times sine 4x equals negative root 2. Divide by 2, divide by 2. Remember, we're isolating that trig function. And I am anticipating 2 times 4 answers, 8 answers. Let's quickly take a look at sine of 4x. So sine 4x, y equals sine, forgot the 4x. Check out the frequency. The frequency is changed, increased by a factor of 4. So sine 4x equals negative root 2 over 2. Let's run the horizontal line, negative root 2 over 2 through that graph. And look at all those beautiful answers. 1, 2, 3, 4, 5, 6, 7, 8. We're anticipating 8 answers here. We're going to find them all, and we're going to do it with substitution. So let u equal 4x. So if u equals 4x, then the sine of u equals negative root 2 over 2. So think on the coordinate plane, where does the sine equal negative root 2 over 2? The sine is negative in 3 and in 4. And that is going to be here and here. 1 4, 2 4, 3 4, 4 4, 5 fourths. 5 fourths pi and 7 fourths pi. So first write your general solution for u. U equals 5 fourths pi plus 2 pi k. U equals 7 fourths pi plus 2 pi k. Now, what is u? U is 4x. We're going to plug 4x back in. 4x equals 5 pi over 4 plus 2 pi k. 4x equals 7 pi over 4 plus 2 pi k. Divide by 4, divide by 4, divide by 4. And we get x equals 5 pi over 16 plus pi over 2k. That is our first general solution for x in terms of k. We need these general solutions first. Divide by 4, divide by 4, divide by 4. And we get x equals 7 pi over 16 plus pi over 2 times k. These are our two general solutions. We're now going to start plugging in k values and get all 8 answers. Let k equal 0. Those are the easy ones. 5 pi over 16 and 7 pi over 16. Let k be equal to 1. If k is equal to 1, and this is going to give us a hint as to how we're going to quickly find the rest of these answers. X equals 5 pi over 16 plus pi times 2. We need a common denominator. It's going to be 16 times 8 times 8. We're going to be increasing all of these roots by 8 pi over 16. So we end up with 5 pi over 16 plus 8 pi over 16. That is 23 pi over 16. So basically what we need to do is utilize this, and we're just going to be increasing all of our roots by 8 pi over 16. So 5 pi over 16 plus 8 pi over 16 is 13 pi over 16. 7 pi over 16 plus 8 pi over 16 is 15 pi over 16. Keep going. Add another 8, 21 pi over 16. Add another 8, 23 pi over 16. 1, 2, 3, 4, 5, 6. I need 2 more. 21 pi over 16 plus 8 pi over 16 is 29 pi over 16. And then finally, 31 pi over 16. 1, 2, 3, 4, 5, 6, 7, 8. There's all 8 of our specific solutions, and here are my 2 general solutions. So one more time, every time we solve, we're after a general solution and a specific solution. See you all tomorrow.